It is by request. I'm going to have to make this fast. It's halftime, and I just been informed that after the game we're going to do a little family stuff. So I'm probably not going to work through all these, but I will set them up though. So let's take a look at this is from Holt Practice C out of their Chapter 11, which is equivalent to our Chapter 7, which is equivalent to our Chapter 11. And let's take a look at this problem right. First thing I'm going to do is make sure we have secant. So we're using the secant triangle similarity. And we have a 90-degree arc right here. So I'm going to knock out, this is 90 degrees. And my wife just looked at me and said, no work. You're done for work for today. Okay, so I have a right triangle because this is 90 degrees. And I have a squared plus b squared equals c squared. So this is radical 2. Okay, so what we have is outside times whole is equal to outside times whole. So let me go ahead and set that up. Outside times whole, x plus radical 2. Okay, is equal to outside times whole. And people mess this up all the time because this is 1 right here. Okay, so I'm going to have x squared plus radical 2x. I'm going to go ahead and set this up for quadratic form. It's equal to 3. And minus 3 is equal to 0. So I'm going to do the a squared plus, negative b over 2a. Well, the quadratic formula, b squared. And I'm going to call that 2. 4ac, so 4 times 3 is 12, and that's going to be a positive, so plus 12, all over 2a. Okay, that's 14. We can't simplify 14, so negative 2. We're going to take the positive root. Okay, we're going to toss out the extraneous, and that is my answer for x. And that's radical 2, silly me. And that's as far as we could go. That's about 1.2-ish. All right, so let's take a look at the next one. So here we are on number 7. Number 7 is a little tricky. I like this problem. This one intrigued me. So I have the same thing. I'm going to draw my triangle. I'm going to extend this out and call that 4. All right, and I have a 120-degree angle. Now guess what? If I draw this, well, let me draw it in red because I'm going to make an altitude. Right there. There's my altitude. I have, not only do I have an altitude and a radius, which bisects this, all right, I also have a 60-degree angle here, 90 here, and this is 30. So 30, 60, 90. And this is also 4. So guess what? This is also going to be the same thing. This is going to be 4 also. Okay? And I know that opposite my 90 is 2a, so this is going to be 2, and this is going to be 2. All right? And if I did a squared plus b squared equals c squared, I'm going to get 2 radical 3 is this length right here. So this right here is 2 radical 3. And the whole thing is 4 radical 3. Okay? So that whole thing's 4 radical 3. Now we can do our outside times whole. Outside times whole, x plus 4 radical 3 is equal to outside times whole. Okay, whole is 8 plus 8, 16. So we got x squared plus 4 radical 3. And, since b is even, I'm going to do completing the square. So I'm going to make that equal to 80 plus 16. 80 plus 16. What am I doing 80 plus 16 for? 80 plus 48. Okay. So that's 128. Okay. Boom. I'm going to divide that by 2 and square it. So 2 radical 3 squared is 4 plus 4 times 3, which is 12. I'm going to add 12 to both sides. So I have x squared plus 4 radical, this is x by the way, silly me, 3x. See, I'm going too fast. And since I add 12 to one side, I have to add 12 to the other side. There's my plus 12. Dadgummit. I need to slow down. Okay. Need to slow down. Plus 12 is equal to 30, 40. Okay. There we go. Now, that's just going to be x plus 2 radical 3 squared. Okay. Squared is equal to 140. And then I'm going to take the square root of 140, which, good grief, I have to do that in my head. I should grab a calculator for this. Yes, people are looking at me through the window saying, stop what you're doing. So x plus 2 radical 3, oh, not x, there's no x there. I'm just delusional, is equal to radical plus or minus. But of course we're going to take the positive root, 140. Simplify that radical, subtract there, and you got x is equal to negative 2 radical, oh, good grief. 2 radical 3 plus, oh, what's the biggest perfect square that goes in 140? I can't think right now. Something big. Okay. Simplify this radical and you're done. All right. And then if you want to convert to a decimal, you can do that. Next problem. Let's drag that over here and make it a little bigger. The biggest mistake that people make is not finishing this. That is a 9. So we got secant tangent. So secant tangent is nothing more than 11 times, that's 18, 28, 29. Oh, good grief. Who comes up with these numbers? Is equal to x squared. Oops, I forgot something. I didn't even read the problem. We got to solve for this. Oh, guess what? Guess what? You have not done your trig yet. And this is a 30 degree with 9 and 9. Okay? No right triangles playing with this puppy. Okay? Come on, because this is 30. This is isosceles. So 150, so half of 150, 75, 75. This is going to be sine A. Oh, good grief. Over A is equal to sine B. Okay, my writing pad is not working. Over B, so on. Okay? All right. Oh, I'm holding it wrong. I'm holding this little button down. It thinks it's the mouse. Yeah. All right. So, no. This one we omit. Okay. I dotted my I even though you don't see it. And because it's law of sines. We'll come back to that when we do trig. Next. I am out of time. People are staring at me. So take a look at this. I'm just going to tell you how to set it up. We got circle here. Call this x. So outside times whole. This is chord. Triangle similarity is equal to 5x. All right. So you solve for x, plug it in, and do chord again. All right. So it's just a little bit of work and some calculator work and so on. You just knock it out. So you find this, add this up. Here's one chord. Okay. Here's the other chord. Here's your chord over here, and here's your chord over here. Make sure you complete the whole thing by adding an x. And you're just going to call this part over x over here, or something like that, whatever was the missing piece. The next problem is almost going to be identical. So take a look at this. Here, I'll make it real big because I'm not going to do it all. I'm going to call this x. So I have 3 times 5 plus x is equal to chord times 15. All right? And you're going to solve that chord problem. All right? Once you have x, now what you're going to do is do the chord here, and this is going to be x over here now. Well, let's just call that y. And for this is part 1. Part 2, you're going to do y times, that's 8.6, right? Is equal to 28 times 5, right? And you solve for y. Then you just add and knock it out. Alrighty, so I am done. I'm going to upload this and I'm done for the night. Bye.